looking at exam technique. So for today, because this is a revision session, because it's only a day long and we're trying to cover a year's worth of AS content, we can't do that in a day. So the way that you're going to get the best out of this experience is by engaging with it as much as you can and by using it to focus your revision going forwards. So exam technique is a huge part of why students don't get the highest marks that they're capable of in exams, because they don't have the exam technique. They don't quite interpret questions correctly, they get worried, exams stress them out, etc. So by focusing on your exam technique, hopefully this can improve your revision moving forwards and then help you when you actually come to do your exam. So what we've done today, we're looking at Year 12 chemistry today, or AS chemistry. We've chosen some topics that overlap with other topics. So usually they've got continued content into Year 13. And we're also looking at some of the concepts which are used to summarize other concepts or can explain other concepts. We've also chosen topics that are covered by AQA, EdExcel, and OCR, which are the three main exam boards. If you are on another exam board, a lot of this content will be relevant, but we might not have made it exam board specific for you. Just remember to check your specification. So if you're a Year 13 and you're here, welcome. This is hopefully stuff that you have already been revising, but if you haven't, this is going to be a good revision from what you did last year. If you're a Year 12, hopefully you have just covered all of this stuff, and so this is a revision for you in preparation for next year, perhaps. So have a think as we go through today. In both cases, as we go through this content, what sort of things could they be asking you about in your exam? I think that's a really good way to revise. Think about what could they be asking you in your exam. And if you think about that for both Year 12s and Year 13s, you are therefore planning your revision ahead. You're planning what you need to know. You're planning how you're going to revise. If you don't have exams this year, you can have a little bit of you can breathe a little bit, but this is a really good opportunity now to maximize your understanding, to link together topics within the specification and give yourself a good grounding so that next year, when you go on to do further topics or when you use these topics to explain other topics, you've got a really good grounding. You can support yourself with your learning next year. Again, I would still recommend, if you are a Year 12 taking the full 2-year A-level chemistry, so you've got your second year coming up next year, that you do still take the time to think, what could they be asking me about in the exam? What is it that I don't understand? How can I make those connections in my brain for A-level chemistry? Okay, so what are we going to cover in this next 55 minutes or so? So what I'm going to look at doing is interpreting questions. Something that students find really difficult all the time is getting the questions right. So lots of the time when we read a question and we maybe get a little bit panicked by it, or it's new to us and we're not sure about it, we interpret a question in the way that we want to interpret it and not the way it's meant to be interpreted. So one of the things that we can do, or we're going to do today, sorry, is help you to understand what are they looking for from you and how can we get there. We're going to look at how to set out answers. Now, I think this is something that lots of students already have skills in, because, hopefully our understanding of when we need to write a short answer and when we write a long answer, when we need to write a mathsy answer or when we need to draw something, hopefully that's semi-clear, but we'll just go through it just to double check and to make sure you're not doing too much in an exam and wasting your time, but also make sure you're not doing too little and missing out on those extra marks. We're also going to look through a variety of examples of command words and then what those command words mean for you. What are they expecting from you when they give you that command word? What do they want from you? And then we're also going to look at some tried and tested exam wisdom. So we'll have a look at what some of the past paper examiner reports have said in the past. And we're going to look at what we, as experienced teachers and tutors, think is a good way for you to approach these questions and answer them, and hopefully get full marks. So just some general points from examiners. questions, this is from an examiner's report in the past. So this is what examiners have said about previous exam papers. Every year they release reports that describe how a cohort did and how they approached questions, etc. This is from one of those reports. It says, questions that demanded an extended response proved tough, and only the best students were able to organize their thoughts into a logical sequence, enabling them to score the highest marks. So, it doesn't take a genius to work out what that means is the longer questions students didn't do as well at. So if you can be coherent and logical with your thoughts, you are more likely to get those higher marks. Key lessons from this paper are the need to develop mathematical skills and to place a far greater emphasis on doing and understanding practical work. Now, we know from the current specifications that they are much more practical heavy, and that paper 3, which is usually the practical paper, is often the one that students find hardest, because it is hard. So, but that is also reflected in previous papers. So just another thing to think about, if you want to focus your revision, focusing it on mathematical skills and understanding practical work is probably a good idea. Another examiner report said less able students did not use correct scientific terminology. For example, they interchanged the words atoms, molecules, ions, radicals, elements, and compounds without understanding what the correct word should be, and they were careless in the way they drew structures of organic molecules. Now, if you don't know the specific differences between those key words, that is 100%, I think, something that you should do even tonight, maybe, is make sure you know what the difference is between those things, because they are different. They have very specific differences. And then in terms of our organic molecules, an easy mark to drop is if you've been asked to draw a displayed structure or displayed formula and you don't draw all the bonds, well, then you haven't drawn a displayed formula. So, yeah, that's another thing that I'll mention again, I'm sure, but another thing to think about. Are you drawing what you're expected to be drawing? Okay, so when you are going through your revision, past papers or doing questions, I should say, is a proven way to improve your exam mark. It's much, by far and above the best way to increase your grade, and most effective revision is doing questions. Now, I know that that's scary, and I know it's hard to work out which questions to do and how to do it. So perhaps maybe set yourself a past paper or two every couple of weeks. I would take the time now to work out within your specification, within your exam board, which topics appear in which papers for your exam board. And just bear in mind, when you go through past papers and when you go through questions, lots of the specifications changed in 2015, and there's a couple have had another update as well in 2018, and there are a couple, I don't think AQA, OCR or EdXL, but there are a couple of exam boards that had an update in 2022 as well. So just bear in mind, be aware that specifications have changed recently, recent enough that stuff that you find on the internet may be for previous specifications. So most of the content is the same, I will say that. They just have edited sometimes the way they ask questions, and there is a little bit of extra content in some specs and some content has been taken out. So just make sure that you're using past papers that are for your current specification, or just be clear that it could be old ones, and so just pay attention to that when you're answering questions. Okay, so the newer papers that you take have fewer multiple choice questions. So they've decided that multiple choice questions are not the best way to determine whether students have an understanding. They have more calculation questions in, which for some students, that's a great thing. And I know for others that they find that a bit harder. But the questions, the calculation questions that they have are more of the unstructured kind. So you might find sometimes that calculation questions have part A, work out this, part B, work out this, part C, work out this, and then part D, therefore work out this. Those are structured calculation questions. Unstructured calculation questions are where they say, question 1, find this. And they give you no structure, no guidance about how you're allowed to get there or how you can get there. And that's an unstructured question. And students find that quite difficult because lots of students can't see the kind of the progress through the question. And there unfortunately are a few more of those in the newer exam papers. There are a noticeable number that are based on practical techniques. And this, as I said before, are things that students find particularly difficult. And I can totally understand why, because we don't spend that much time doing practicals. So they are really difficult to do. But just bear in mind when you're doing your past paper questions that it's a good thing to focus on is your practical techniques. And there are more questions that require an extended written answer. So those longer answer questions, those long form questions, which you will also get marks for your communication, scientific communication, keyword use, etc. So there are more of those as well. Oh, and just as an aside, because I know that lots of students find it a bit frustrating, perhaps, that there is more practical questions in the exam, and they are hard. This is because there isn't any coursework at the moment. So the payoff for not having to do coursework is that you get more of these questions in your exam. Okay, so what I will try to do throughout the day today, whenever we go through past paper questions, is I'm trying to help you to break down the question. I'm going to try give you the structure that you need so that when you approach any exam question, you can prepare yourself for it and then, hit the ground running with it. This is an example from an AS paper. And there are three key things, that it would be a good idea if you can identify when you come across a new exam question. The first thing is the context. So that's usually the first thing that I look for when I come across an exam question. I say, right, what part of the specification is this relevant to? What topic, what chapter, however you've set out your revision or however you've learnt your content, what am I relating this to? So just going to green. So in this case, it says a sample of sulfur consisting of 3 isotopes has a relative atomic mass of 32.16. Table 1 gives the relative abundance of 2 of these isotopes. Then it gives table 1. So it uses information to determine the relative abundance and hence the mass number of the 3rd isotope. Give your answer to the appropriate number of significant figures, and it's worth 4 marks. So context in here for me is that we're talking about isotopes. So in my head, I'm getting rid of, or I'm finding the revision sheet in my brain on isotopes. So that's what I'm looking for, isotopes and relative atomic mass calculations, etc. That's the context for me. Command words. I'm then thinking, right, what are they expecting from me? What am I giving a statement, a short answer, a long answer, an essay, a calculation, a drawing? What do they want from me that's to do with isotopes and relative atomic mass? So here, most questions, not all questions, but most questions will use very specific command words. So here we've got use this information to determine the relative abundance. So determine is a very specific keyword, and then give your answer to the appropriate number of significant figures. So those are our command words. They are telling us what form we must write the answer in. And finally, once I've got that, so determine, I know I'm looking to use the information that's been given to come up with an answer, and then I'm giving a short answer as my final answer. Then I can say, right, what are my directions? What extra bits of information, what guidance has the question given me to help me towards an answer? So in this case, I've been given, for example, the table full of isotopic abundances, relative abundances, etc. I've also been told to use this information. So even though the word determine, the command word determine already tells me that I need to use the information, I've got use this information in there to determine the relative abundance and also appropriate number of significant figures as well. They have asked me for an appropriate number of significant figures, so I must make sure I give it. Otherwise, I could lose a whole mark for giving the wrong number of significant figures. So then I can have a go at the question. I'm thinking it's isotopes. I'm thinking I need to use the information that's been given to determine an answer, to determine the 3rd isotope, and then I'm going to give my answer. Now, I will say in this exam technique section, we won't be able to go through in lots of detail all of these exam questions because we just don't have time, unfortunately. But we will give you these answers now together as we go through them, so you can just have a quick think about how you might do the question, what you think the answer might be, and then see if your answer agrees. And then later on, perhaps you can have another go at it a bit slower on your own, and then you've got the answer to compare it to as well. I will say as well, in case people have been asking, the answers to all of these questions that we have in the booklets will be emailed out to you when you've completed your feedback at the end of the course. So you will get all the answers, I promise, at the end. So yeah, please don't panic. You will get those. Okay, so if you were to do this question, we would have a look at, we would hopefully remember the relative atomic mass equation, which is the sum of the isotopic abundance times the mass number of that isotope. So sum all of those up and then divide by the sum of all isotopic abundances, which is usually 100. So in this case, there we go. Relative abundance of the third isotope must also therefore be 72% because the others add up to whatever the difference is, 93, 92.8. So I would therefore get the relative atomic mass of 32.16 must be equal to, I've input all the numbers I've got, the number I'm missing is Y, that's my isotopic abundance that I'm missing, and divide by 100. So Y, the relative abundance must be 33.972, sorry, which is 34 to 2 significant figures. Okay, so we're giving it to 2 significant figures because sorry, let me rephrase, the fewest number of significant figures given in the question is 2. So I can't give an answer to more than 2 significant figures. My relative abundance percentage there was given to 2, so I have to give it to 2. So final answer, mass number is 34 to 2 significant figures. Okay, so just to confirm, we're not going to go through all of the questions in a huge amount of detail, because otherwise we will just spend all day doing it. I could easily spend all day doing it. But this is the format of today. This is what we're going to do. So let's continue interpreting some questions. Again, don't forget, you can use let me get the email address correct, seminartutor@tutors@snapprovides.co.uk. You can email that to at any point during today to get clarification on things, to get extra support if you need it, or you can messenger us on Facebook Messenger as well, if you need. Okay, so you'll find that questions tend to come in 4 different question types. Statement questions, which tend to be between 1 and 2 marks, short answer questions, which tend to be 2 to 3 marks, calculation questions, which can be anything from 1 to 6, and long answer questions. And we're going to go through each of those in a bit of detail now. Sorry, you will see me drinking regularly throughout today and tomorrow. Oh, why has it done that? Sorry, guys, the external screen disconnected. So let's try and reconnect it again. Hopefully that's sorted it. I think that's sorted it. Okay. Forgotten where I got to. We'll go through each of these individually, look at them in a little bit more detail, think about what they mean for us as examinees, as students taking the exams, and I can give you any extra information that I can. So, statement questions. These are the ones which students find a little bit more reassuring because it's rote learning, and most students prefer to rote learn because you know where you stand then. So this is your ability to remember facts. Now, quite a lot of the specification is facts, but not all of it you need to be able to rote learn. There are still, within chemistry, it's a lovely balance between application of knowledge and recalling facts. And what I would highly recommend, and I'll say this multiple times throughout the next 2 days, I'm sure, is the more you know your specification, the easier you're going to find revision and the exams. So statement questions, they're usually a test of rote learning. They usually require information which you can often take directly from the specification, which is perfect. So you can use the specification to your advantage to know exactly what it is you need to know. There might be, within a statement question, some context that you need to apply. So you're going to need to interpret or extract information perhaps from the question to work out exactly which fact you need to recall. But it will be short, specific to the point, and rote learning. So command words that you might see that will help you to think, well, this is a statement question and this is recalling what I need to know, are things like name, state, define, write, balance, construct. Sometimes these will be just recalling the rote learning, identify or determine, and some multiple choice questions are recall questions. There's also some drawing questions, which if you wanted to, you could rote learn answers for. So examples of each, it might be name the mechanism for something. It could be state the conditions. It could be define the term, identify the compound, or draw the product. All of these for you could be a recall or rote learning exercise for you. So when these questions come up in an exam, you're going to need to recall the content. For chemistry, I think most students find it easier if they understand as much as they can, and then you don't have to remember as much. But I know that that's hard. Not everyone can do that. There's so much content to understand. It's very difficult. So I do get that. So there's a lot of content that you can that you might need to recall as well. What else was I going to say here? Oh, yes. So in your specifications, so I'm going to say this multiple times, know your specifications. No, it doesn't matter which exam board you're on. If you don't have a copy of your specification in front of you now, I would get it. Print one off, find it wherever it is, get it up on another tab, whatever, get it in front of you. Because the more you use it for your revision, the easier you're going to find your revision. The more you know your specification, the easier you're going to find your exams. Specifications to me, and I know the exam boards are slightly different, so I do prefer some specifications to others, but they're basically a checklist of everything you need to know and how you need to know it. That's what a specification is. It's what your teachers have been using to teach you. So a specification is really, really important, I think, in your revision. So get up in front of you and learn to understand it, learn to interpret it. Because in your specification, if you see phrases such as know that, or state that, or define the term, whatever, that's telling you you have to be able to recall this. You could be asked to recall this in an exam. So know that, state that, define. These are things that you'll find in your specification that will help you to understand that this is stuff you need to recall in an exam. Okay. Etc. So go through your specification, perhaps with a highlighter, and highlight those bits. This is stuff you need to be able to recall in your exam. So you either need to understand it well enough that you can work it out without recalling it, or you need to sit there and rote learn it with your flashcards, with your mind map, teach a friend, whatever it is that you want to do, teach your parents if you need to learn it off by heart. Read, cover, repeat, whatever. Okay. So statement questions, command words that you're going to be given. So name or state. If they ask you to name or state something, then all you need is a simple 1-2 word answer, maybe a short sentence if it's you're defining a keyword or they're expecting a little bit more from you, perhaps a short sentence, but you don't need to give any justification, no description or anything is needed or explanation required. You just need to make sure you're using your scientific terminology correctly. So if you start talking about ions and you mean electrons, or if you start talking about atoms and you mean molecules, you won't get the mark. But you don't need to to describe anything. You don't need to explain anything. So don't waste time writing more than's necessary. Don't go into an explanation of a theory if all they've done is ask you to define Hess's law, for example. You might be asked to define something, and in your exam board specifications, there should be a lot of, you need to be able to define this. You need to, students must be able to define these keywords. If you ask for a definition, most definitions are going to be at least a short sentence. Sometimes we can get them down to a concise few words, but basically it's a short sentence. So make sure that you're giving a sentence rather than a single word if you ask for a definition. It's best if you know the standard wording, and by standard wording, I mean, if you don't use the right keywords, you might not be given the mark. And unfortunately, different exam boards expect different things from you. So somebody in an exam board has determined that's what I want you to do. And you just have to learn that one. So learn the ones that are specific to your exam boards. If you're not sure, or you've seen multiple ones, or maybe your textbook gives a different one to the one your teacher gave you, you might have to just spend a couple of minutes finding a mark scheme from your exam board. Use the mark scheme, that'll tell you the wording they want. Or look in your specification, because often specifications have got the exact wording they're looking for in them. So use your specification. So it's best if you know the standard wording for definitions, etc. So this is an example of a short answer question, or a statement question, sorry. Precipitation reactions can be used to distinguish between halide ions. State the reagent needed for these precipitation reactions. So how do we approach our questions? I'm approaching it, first of all, I'm thinking, right, context. What area of my revision do I need to be thinking about right now? Precipitation reactions and halide ions. So that's what my brain, that's the context that my brain is looking for. Precipitation reactions and halide ions. What command word, what sort of answer are they looking for out of this? What am I thinking about? It's a statement question, so short answer. Probably 1 or 2 words, no more. Definitely no explanation needed of why. And then what directions am I being given for the answer? So I'm looking for the reagent for the precipitation reactions. That's my directions, the reagent needed. So what is it? Hopefully we know. Oh, sorry, I didn't write. Directions. I didn't write context there. Let me just do that. Command word, sorry. Command word. Apologies for my handwriting, by the way. I will do my best to verbalize everything I'm writing so that you can see what I'm supposed to be writing if you can't read my handwriting. But I will do my best. If I can see it, it's illegible, I'll try and write it again. So hopefully you recognize that you need silver nitrate or AgNO3 for these as your answer for the precipitation reactions. Look, as we can see, it's only a short word. Sorry, this is only a 2. If you write it as the word, it's only 2 words. If you wrote it as a formula, which is acceptable, then it's a single formula. So short answer. Oops, I went too fast. Okay, so what about if you've been asked to identify or determine? So if you've been asked to identify or determine, you need to select key information, sometimes given in the question. Well, in fact, most of the time it's given in the question. Or at least your guidance is given in the question. So look carefully at the context of the question and consider all possible options, eliminating incorrect answers. The key with these questions is you're not being left on your own. And in fact, if a lot of the time identify and determine questions are ones that students get wrong because they think, oh, I can name a random alkane, but actually you're supposed to be naming a specific one that fits within the guidance of the question. So just be super careful that you're answering the question that's been given and that you're using all the information to get to that answer. Perhaps your short answer, statement question is a write or balance or construct command word. Maybe they've asked you to write, balance or construct. So if you have, it's usually been because you're being asked to write, balance or construct a chemical equation or an equation that represents a process or a reaction. So they should always be balanced. They need to have balanced mass, so no losing atoms. They need to also have balanced charge. So you shouldn't have random electrons floating around. You shouldn't have different charges in the reactants overall as you do in the products, because that means you've gained or lost electrons that have just disappeared off into the ether. So make sure they're balanced, but look out for whether or not you need state symbols. So it took me, and I've been teaching for nearly 9 years now. No, sorry, nearly 10 years now. It took me a long time, even as a teacher, to work out when you need state symbols and when you don't. And I know that it's a big confusion amongst students. The key is they are only going to be interested in state symbols if it is important to the process, reaction, or equation. What I mean by that is some of the processes have to happen in the gaseous state. And if they have to happen in the gaseous state, you need to give those gaseous state symbols in your equation. Because if they don't, if that process doesn't happen in the gaseous state, it's not that process. So look out for whether or not state symbols are important or key to a process. If they are, include them. If it wouldn't matter what the state is, or if it's not important for that process, then you likely don't need to give them. Obviously, if they've asked for them, give them. But if they haven't asked for them and it's not necessary for that process to occur, then you shouldn't need them. Or they won't be offering you a mark for them anyway. So an example of one of these types of questions would be this one. Bromine can be extracted from seawater containing bromide ions using chlorine. Write the ionic equation for this reaction. State symbols are not required. So context, which area I'm looking at? This is extraction of our halogens. What's the command word? Write. Not sure what's happened there. Let's come back. Have we come back? Yeah. Write. Write is the command word. So I'm looking for probably an equation of some kind. Ionic equation specifically. And that is my direction. So I'm looking for the ionic equation for this reaction. Have a think about what you might write if this were your exam paper. Part 2, identify one hazard associated with carrying out this reaction in a school laboratory and a safety precaution other than wearing a laboratory coat and eye protection. So again, still the same context, but my command word is identify. So choose from the hazards that you're aware of that are specific to this question. So it's identify because you've got a context. It's got to be specific to this reaction. It can't just be a random hazard that's specific to a different reaction. It's specific to this reaction here. That's why they've given us the word identify, not state. They said identify. And specifically, the directions also is it's got to be something other than wearing a laboratory coat. It's got to be useful in a school laboratory, and it's got to be other than wearing a lab coat and eye protection. So what might you put for that? Let's have a look. So if you were giving an ionic equation, you need to make sure you've not included your spectator ions and that you've got a balanced equation otherwise. So 2Br minus plus Cl2 goes to make Br2 plus 2Cl minus would be our ionic equation. 1 mark for all of that. And then a hazard you could give might be something like that's specific to this reaction, might be something like chlorine is a toxic gas, so the experiment should be carried out in a fume hood. Something like that. 2 marks, 1 for giving your hazard and 1 for giving the safety precaution to deal with it. Okay, what about if you're given multiple choice questions? So multiple choice questions, we've said there are fewer of them in these exams coming up, but they are still going to be present, obviously. Often there's 1 totally wrong answer and 2 answers that are deliberately chosen to confuse you. Yay. They're usually testing common misconceptions. Sometimes there's 2 totally wrong answers, or you might see 2 totally wrong answers because you have completely, you've nailed it and you haven't gone anywhere near a misconception. And if that's the case, you might notice that there are actually maybe 1 or 2 answers that you consider to be clearly wrong, and you're then choosing a 50-50 perhaps. But know that there is usually at least 1 answer that is completely wrong that you should be able to eliminate quite quickly. Then you might have to choose between the next couple. So if you're running out of time, eliminate the ones that you're pretty sure are completely incorrect. And if you're not sure which is correct out of the other 2, then unfortunately, guess. But if you've eliminated a couple, it might be 50-50, which is much better odds than 1 in 25. So 1 in 25, sorry, 1 in 4. Or 25%. So if you're running out of time and you aren't sure, eliminate, but put a star and come back to it if you can at the end. If a calculation is required, and often they are for only 1 mark, which is hard, the incorrect answers will be chosen to reflect some common errors. So again, if you're unsure, put a star, come back to it. Show your workings so you can come back to it easily and you can track and see if you have made a common error, but come back to it at the end. So a couple of examples of multiple choice questions are these. Water is a polar covalent molecule. The strongest intermolecular forces between water molecules are hydrogen bonds. The OH bond in water is polar because when compared with the hydrogen atom, the oxygen atom has context. I'm not going to be able to write in context and stuff for all of them, but let's get thinking. Context. I'm thinking water is a polar covalent molecule. Strongest intermolecular forces. I'm thinking intermolecular forces then, bonding and structure. Intermolecular forces, that's my context. The command word, there isn't technically a command word here because it's a multiple choice question, but hopefully we can see what they're looking for from us is to select one of the answers. And then directions, specifically, I'm explaining why water is polar. Why water is polar. So when compared with the hydrogen atom, the oxygen atom has, we'll come to that answer in a second. Think about which one you might give. Question 2, or the second question on this page, sorry, says a student is provided with a 5 centimeter cubed sample of 1 × 10⁻² mole per decimeter cubed hydrochloric acid. The student is asked to devise a method to prepare a hydrochloric acid solution with a concentration of 5 × 10⁻⁴ moles per decimeter cubed by diluting the sample with water. Which of these is the correct volume of water that should be added? Again, have a think about what you might put, but if you're not sure, what's the context? The context is that we are looking for, preparing solutions. So amounts of substance, sort of, but specifically preparing solutions. This is actually a bit more of a practical question. So one of those practical questions that we spoke about. The command word, again, there isn't a specific command word. You could assume that which is a command word. It's not usually listed as a command word, but we can see what we're expected to do is to choose one of those answers. And then specifically the directions are I've been given these amounts. I've been given 5 centimeter cubed sample of a concentration of hydrochloric acid, and I'm supposed to be preparing a hydrochloric acid solution with a concentration of 5 × 10⁻⁴. So how do I get there? What answer would I give? Let's have a look at these two. So question A on our slide, the correct answer here is that oxygen atom has a greater electronegativity. Now, interestingly, within this question, they are technically all correct in that they are all correct for oxygen compared with hydrogen. But none of the rest of them have, well, more electrons does have an influence on electronegativity, or that our idea of polarity and dipoles and stuff. So that's in there as a little bit of a what's the word? That's an answer that you might get confused with, perhaps. Larger atomic radius is similar to more electrons, I guess, and the higher mass number. Well, when is higher mass number? We've never used that as a way to talk about electronegativity or bonding and structure, etc. So that's definitely wrong. B and D even do have a connection, but they're not explaining the answer. They are not the cause of the polarity difference between hydrogen and oxygen, which is why the bond is polar. So it has to be C. If we're answering the question fully, it has to be C. The second question on this page, well, we need to do a little bit of calculation to do with this. So you might be able to visualize it. You might not have to do the calculations, in which case, brilliant. But if you do want to see the logical steps through it, we've written them up on the side here. So the moles that we have originally is 5 × 10⁻⁵. So we've done concentration times volume over 1,000 to get the moles. The volume of our new solution needs to be 100 centimeters cubed. Oh no, it doesn't, sorry. The volume, apologies. Our ratio of volumes between our oh no, sorry, this is a different method. Okay, sorry, this is the C1V1 equals C2V2 method. Sorry, apologies. So this is this idea that, although actually we've done it in the longer form, if you may have done it already in class, C1V1 is equal to C2V2. This is when you're doing a dilution of a solution. The moles, if you haven't changed the moles or the molar amount, then you have a lovely ratio of the initial concentration times the initial volume. which is equal to the moles, is also therefore equal to the final concentration times the final volume. So if we arrange that to find the final volume, our final volume is 100 centimeters cubed. The question, however, has asked which of these is the correct volume of water that should be added, which is where lots of students will have tripped up. So option C in here is the mean answer that's there to trip you up. The question says, which of these is the correct volume of water that should be added? So we've started with 5 centimeters cubed. We're aiming the final volume should be 100 centimeters cubed. So we need to add 95. And that's where lots of students will have tripped up. Interestingly, because I can see that the solution is, the concentration is going from 1 times 10 to the minus 2 to 5 times 10 to the minus 4, in my head, I can see that we need to get it, that we need to get it to 100 centimeters cubed. So in my head, I can visualize that. But if you can't, that's absolutely fine. You can just do it using C1V1 equals C2V2, or working through, work out how many moles you start with. You need that many moles to end with. You've been given a concentration, so you can work out the volume. So have I got a dot there? Yes. So that's the answer for that one, B. Okay, what about short answer questions? I need to speed up a little bit. What about short answer questions? So short answer questions require only short or approximately 2-line answers. They test your understanding of general principles or the meaning of qualitative results. So can you describe what has happened? I nearly said explain then. Can you describe what has happened? There's not usually an explain, but you can have an explain. And they can be combined with calculate questions. So example command words are explain, so explaining a short explanation explaining a concept, a short description describing a concept or a theory or a practical or a result. You could be asked to suggest or predict a result, or suggest or predict a structure of something that might be formed. You could be asked to plot or sketch a graph, or you could be asked to draw something. These are all shorter questions. For example, explain why. You could be asked to explain why, describe how, suggest why, plot a graph of, draw the mechanism for, etc. Oops, sorry, I meant to say, again, in the specification, you're looking for phrases such as know that, understand that, describe that. Students should be able to explain that, etc. So that's what you're looking for in your specification. Again, get comfortable with your specification. Use it to work out what you could be expected to explain, describe, draw, etc. So if you've been asked to describe, what you need to do is describe what is happening, or what you can see. So what observations might a student doing the practical that's described, what might they be able to see, what might they observe? Perhaps you've been given a graph that you need to describe, perhaps you've been given a diagram you need to describe, perhaps you've been given an experiment that you need to describe. If you've been asked to explain, make sure you explain every step of your reasoning. Pretend examiners are not clever, and they need every step of the explanation in order to understand it. You can't skip steps because you think it's obvious. You have to show your examiner that you understand it. So you might need to, for example, show how a process will progress, giving a well-developed line of reasoning which is clear and logically structured. Again, just make sure you include all the steps. Don't skip over a step because you think it's obvious. Your examiner needs to know that you know it, so make sure you include it. So, for example, describe and explain the change in the rate of the reaction during the first 200 seconds of the experiment. Concepts, we're thinking rates of reaction. So the context, is rates of reaction, kinetics. My command word is describe and explain. I've got 2, so it'll be 1 mark for each. Describe and explain. And then specifically, I've been given a graph to look at that I need to understand and then describe and explain. So what answer might you give? Well, hopefully we know that rate is equal to change in concentration of a reactant or product over time. The rate in this case is going to be the gradient of a concentration or mass time versus time graph. In this case, we've got mass over time. So our answer needs to describe and explain the change in the rate of the reaction during the first 200 seconds. So we can ignore the end of it. It's another bit. An exam, just as another exam tip, the number of lines, dotted lines you're given, gives you an idea of how long the answer needs to be. So if you've been given more than one dotted line, you probably need to include a sentence. It probably needs to be a sentence. Here we've been given 3 dotted lines, so we're probably thinking a decent sentence. Probably don't need 2 though, so just a single decent sentence. So what would you give here? Hopefully you'd say something along the lines of, what's happening? The rate of reaction is decreasing as the concentration decreases. What's the explanation? So that was our description. What's the explanation? Because there are less frequent collisions. We can't say less collisions in this case because it's a rate. They have to be less frequent. Or you can say fewer collisions per unit time. That's fine, as long as it's to do with frequency. Okay, what about if it's a suggest or predict? So application of knowledge questions. These are we're applying knowledge to novel theoretical and practical concepts. You need to determine which topic is related to the information and then apply relevant knowledge to it. These students find quite difficult because it's stuff that you've not covered, but you do have all of the content that you need, okay? Often information or context not on the syllabus will be provided for you. So you don't have to have a panic about not knowing stuff. All the information you need has been given to you. So you can apply content from the specification that you know to this new area. Suggestion questions usually include another command word, for example, suggest an explanation, suggest a name, suggest a description for, etc. For example, anti-bumping granules are placed in the flask when refluxing. Suggest why these granules prevent bumping. So you might have seen anti-bumping granules used for distillation. This is a new context. This is within refluxing. So you know them for distillation, so you can use that knowledge to apply it to reflux. I'm going to whiz forward just because I know that we're a bit short on time. For example, you might say here, the granules prevent the formation of large bubbles by encouraging formation of smaller bubbles. Something like that. Or by encouraging the regular formation of smaller bubbles. What if you've been asked to plot, sketch, or draw? It's really, really important, and students often lose marks because they draw a tiny, tiny little graph on a tiny bit of the graph paper they've been provided. Make sure that your axes and your scale are as big as they can be. You need to take up 2/3 of the graph paper if possible, and that they're clear and that your scale is correct. So you haven't changed scale halfway through your axes, etc. That tends to be the bits that students find hardest. Do practice graph questions. I know they're long and I know they take forever, but they usually come up. You'll usually have at least one graph question in your exams. So practice them because they can be a nice, easy, just plotting your points. So do practice. Practice makes you faster and less likely to make silly mistakes, and then you don't drop marks that you could have otherwise got. So, for example, I'm not going to go through this one because I would need to draw out the graph and we are short on time. I just want to make sure that we've got enough time to do everything. So here we've been asked to deduce amounts of X and Y equilibrium. So we would do the following. I'm going to leave you to do that in your own time, and then we would need to plot a graph. Our graph would end up looking, oh, no, don't do that. Sorry, pressed the button I didn't mean to press. End up looking something like that. Oh, that's meant to go straight. But we will email out the answers to you, so don't worry. Once you've filled in your feedback forms. What else was I going to say there? Can't remember. Okay, I obviously haven't drawn an axes or labelled the axes, which I should do. I should also make sure I've got my units on there as well. But again, you'll have the answers, which will have all of that in it. Okay, what about if you've been asked to do a calculation question? So calculation questions are quantitative questions, so they're looking for numbers, amounts. It usually or often includes a recall of equations. Sometimes it's the simple equations that we learnt way back at the beginning of year 12, moles equals conc times volume over 1,000 or something like that. But usually you'll need to do something that includes an equation that you have to have memorized. It may require interpreting data sets, figures, equations, or graphs to obtain values required for a calculation. And they may have multiple dependent steps. which mean if you can't do the first step, you think, I have to be able to work out that number of moles in order to move forwards, but you can't, just make up a number. Just say, assuming the moles are blah, 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 and then use it moving forwards, because you at least get the method marks for the rest of the question, even if you didn't get the mark for working out the moles correctly. So if you can't do a step, keep going and get the error carried forward marks. Often you can get most of the marks, even if you make an error at the beginning. So definitely worth it. Command words, hopefully a little bit clearer for calculation questions, is going to be calculate, determine, and there might be something that says you have to determine something and then show your working. Make sure you show your working. Even if it hasn't asked for it, I would always recommend showing your working. It's so difficult. I have been an examiner in the past. It is so difficult when a student is giving you an answer and you have got, and it's wrong, and you've got no idea how they got there, so you can't give them any working marks. So you should always show your working. It also helps you for when you go back to check, if you have time at the end of an exam, when you go back to check your calculations, you can follow your own steps through and go, oh no, I've added those instead of timesing them. That doesn't make sense. So you can go back and check it and edit. Examples would be calculate a value, determine the value of, or determine the whatever, and show your working, funnily enough. Again, in the specification, you're looking for things like calculate, funnily enough, or determine. Students should be able to calculate, students should be able to determine. If they have asked you to calculate, you're going to need to give a numerical answer to the correct number of significant figures, and you must give units, obviously. You need to set your workout step by step, include all of the steps, however small, I've already said that, and you usually get a mark for each piece of working. Sometimes if you have to work out moles twice, you'll only get a mark for working out moles once, but you still need to work it out twice, so still got to keep going, unfortunately. State any relevant formulae that you are given, even if you can't use it, even if you're not sure how to use it, just give some formula that you think might be relevant, because in some cases you can get a mark for it. Here's an example question. One thing I will say, actually, for questions like this, especially if you are somebody who struggles with the practical aspect, is I will always, even now, if I come across a new question I haven't done before, I will always draw out an example setup, because I find it easier to visualize then what's happening. So here it says, a student was asked to design an experiment to determine the value of the MR for MHCO3. The student dissolved 1,464 milligrams of MHCO3 in water and made the solution up to 250 centimeters cubed. So I'm going to draw out somebody putting some solid into, and I'm going to number that as 1,464 milligrams, and they're putting it into 250 centimeters cubed. I've then made it up to 250, fine. 25 centimeters cubed samples of the solution were titrated with 0.102 mole per decimeter cubed hydrochloric acid. So I'm going to take 25 centimeters cubed of that solution and titrate it with 0.102 mole per decimeter cubed hydrochloric acid, etc. So I can see, that looks a bit like a D, doesn't it? Let's make that a 0. I can see what's happening now. I can follow that a lot easier. You might not need it, that's absolutely fine. But if you do, this is a way that I approach calculation questions. I know the context is titrations. I've been asked to calculate, that's my command word. And specifically, I've been given all the data that I need. To calculate mean titers, you do need to make sure you use concordant titers. Now, they're different for different exam boards, what they class as a concordant titer. For EdXL, they must be within 0.2 centimeters cubed of each other. And if you're AQA or OCR, they are within 0.1 centimeters cubed. So just bear that in mind. This one here that's been given is an AQA question. So if you are EdXL, yours might be slightly different, but here it's this is AQA. This is because we have to make sure when you're reading a burette, depending on where your eye line is, you can read it off differently. We're supposed to all read it off the same. We're supposed to read the bottom of the meniscus. Oh, let's just turn the screen off again. Sorry, it's just disconnected itself again for no apparent reason. I think we're back. Yep. So depending on where your eye line is, you might read the bottom of the meniscus off at a different point. So we need to use concordant titers to make sure it's not just human error that has caused different readings. And remember as well, rough titers are not used. So you can't use rough titers. And in this case, that value that they got first is not concordant. So we wouldn't use that value to calculate the mean titer. So if you were to have a go, this is what answer you would get. I'm not going to go through it now because we are low on time. And you'd need to use your C and N equals CV equation, which you could put into a triangle if you wanted. Please feel free to have a go at those. Again, we will send the answers over at the end. So some top tips now for maths. Just make sure you can rearrange equations, either using an equation triangle or just rearranging equations as you would do without a triangle. Make sure you can solve quadratic equations. Now, it feels really weird because we haven't done quadratic equations since GCSE, but it is expected that students have a GCSE level knowledge of maths. So you could be expected to use the quadratic formula. Maybe. You probably won't, but you could. So have a go at solving quadratic equations. Maybe just do a couple, just remind yourself. It should come flooding back, I'm sure. You need to understand ratios because they come up all the time. Look out for units. Set up little red flags for yourself. Whenever there is a weird unit, set up a little red flag. So as soon as that topic comes up, you go units. What was wrong with the units? What do I need to remember about units? And practice your conversions because, for example, most of the time when volume comes up, we need to convert it. Does your answer make sense in context? Have you given a massive number, but actually they're expecting an atomic mass, so it can only be between 1 and 118, but your number's 1,000 and something? Feels like you've done something wrong there. So does your answer make sense in context? Make sure you've given it to the correct number of significant figures, because we don't want to lose marks from that. And make sure you've given it to the correct sign, particularly in enthalpy calculations. I have a little red flag that goes up with enthalpy calculations that says I need to make sure that I give a positive or a negative, because enthalpy change has a positive or negative. It has a direction, as it were. 20% of the overall assessment minimum will contain mathematical skills at GCSE level 4 or above. Minimum. So there will be 20% of your exam will be maths or mathsy. Okay, I'm going to need to whiz through this because I'm running late, as I always do. I love a good natter. Long answer questions. Long form answers tend to be approximately 5 lines or more. They usually are asking you to interpret or analyze, including comparing data, figures, methods, etc. And you need to be able to explain how to conduct experiments with or without diagrams. You need to, often they test practical knowledge in unseen contexts, which I know is super scary. And it might be that you're expected to draw a mechanism. Longer questions, especially the proper long form 6 and above, are marked using levels based on the quality of your writing. Is your answer coherent, logically structured, and with correct use of terminology? If it's not, you won't get full marks. Even if all of your chemistry is correct, if it's not coherent or logically structured, you can't get full marks, which is rubbish. It's all to prep for if you go to write scientific papers or reports and things when you're older in your job. You need to make sure that you can present information in a logical and coherent way. Command words then for this kind of question is stuff like describe, explain or justify, discuss or evaluate or deduce. For example, describe how, explain or justify why, discuss or evaluate the effect of, or deduce why, blah, blah, blah. Again, look through your specification. They do give you hints as to what you could be asked about. So, discuss or evaluate, you need to present key points from a range of arguments or the strengths and weaknesses of an argument or data set. You need to be sure to consider more than one side of the argument and recall relevant facts. That's where we often lose marks in exams. Oh, sorry, I had a thing come up on my screen. I think it's all good. That's where students often lose marks, is that there's a They forget to present the opposite side of the argument. If you've been asked to discuss, if you've been asked to evaluate, even if you think the answer is clearly on one side, so it's clearly a pro or it's clearly a disadvantage, you need to give the advantages as well. You need to give the other side of the argument, otherwise you won't get all the marks. You need to provide a detailed account of each side of the argument using correct scientific terminology. There we go. For example, here, again, I'm definitely not going to go through this because it's a full 6 marker. Here, you've been asked to evaluate the effects of making this change on the rate and yield of this reaction. I'm not going to be able to go through it. I'm really sorry because we are low on time, but we have got an answer here. We will email answers out. Here our answer shows a coherent and logical structure with linkages and fully sustained lines of reasoning. So how do you set out a longer written answer? Well, you set it out clearly. An examiner doesn't want to spend more than a minute looking for a mark. In fact, we're instructed not to. So you have to make sure your answer is written clearly. Think then write. So if you need to, make brief notes if it helps. Maybe you can come back to it later. Refer back to the question and make sure you're answering the question that's been asked, not the one that you wanted to be asked. Make sure you use scientific terminology and keep it simple. The more you waffle, the more chance you have of making a mistake. Okay, and it comes up regularly. Students will waffle and then contradict themselves and lose the mark that they'd already gained. So just be careful. Material that's not required by the question is not penalised unless it's chemically incorrect, but it wastes the candidate's time. Yeah, so just make sure you're not waffling. Also remember, you're not writing an essay in chemistry. We don't have essays, so you don't need full sentences. They just need to make sense. So I'm not saying leave out half the words. I'm just saying you don't need to start with the. You can keep it bullet pointed. You can use subheadings if it's helpful to you. You can use a well-labeled diagram if it's appropriate to the question. And if you're short on time, just jot down equations or key facts in the hope that you could gain a mark for them. Leave a question and come back if you're drawing a blank, because another question might prompt a bit of knowledge for you. Candidates should be very cautious about writing long answers, as this can increase the possibility of contradicting themselves and can reduce the clarity and coherence of their answers. So this is something, again, as I said, that students struggle with. Right, finishing up here. Again, if you've got any questions, don't forget you can message the us on Facebook Messenger or use the email address given at the beginning. But top tips just to finish up here. Make sure you can distinguish between what you need to learn, so what you need to recall, what you need to understand, what techniques you need to master, so drawing, for example, drawing graphs. Whoops. And again, use your specification to work it out. What do you need to recall? What can you just understand and be able to apply? What do you need to understand, etc. So use your specification to help. Know what you need to know. For example, don't learn things if you don't need to learn it. Different exam boards do expect different things from you. So use your specification to check that you're doing what's required. This is a key example. If you are, which one's which? That's AQA. If you're AQA, you have to be able to define relative atomic mass and define relative molecular mass if you are AQA. If you are EdXL or OCR, you don't. It specifically says definitions of these terms, relative molecular mass and relative formula mass, is not required. So if you're AQA, you do need to be able to give a definition for those. If you're EdXL, you don't. Same with OCR. It gives you information about relative atomic mass, but then it says, where is it? Definitions of relative molecular mass and relative formula mass will not be required. So use your specifications to make sure you're not doing extra work when you don't have to. As well as the specification being my favorite resource, I will not stop going on to my students about periodic tables. They are a resource that's given to you in an exam that provides you with so much more information than you can possibly believe. You can relate so much of your revision to the periodic table, and it's given to you in an exam. So if you can use your periodic table to help you remember things, why haven't you? Do it, because that resource is given in the exam. So understand what the periodic table can give you. Go through your specifications, see how much you can link to the periodic table, because you should be able to. Master your common formulae. is surprising, and I know because I was one of them, how many students still don't know their common formulae. You need to know it, unfortunately. And if you are somebody like me who finds it really difficult to remember things, just sit down and learn them. Find a way to learn them. Google, lots of people have different ideas. Ask your teacher, ask a friend, ask a tutor, but learn them. So if you don't know them, you will find it so much harder to understand other contexts. Remember your standard reactions. These are all given in GCSE. So you need to know them. So learn them. Again, if you find it hard to remember them, practice, 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 practice. And finally, learn your chemical tests. Again, these are all given to you, are all part of the GCSE specification. So you need to know them. Actually, that's a lie. To varying degrees. I don't think you need to do melting point analysis at GCSE, but you need to understand melting point analysis because you use it to determine if something's pure or not. So all of these things are given at GCSE. Just take 4 seconds now, just see if you can work out what we mean by each of them, because I'm going to write the chemical test next to them. So this one is our melting point analysis. You need to know how to use it, what it's for, analysis. Here we are relighting a glowing splint, so that must be oxygen. This middle bottom one, we're hearing a squeaky pop, so that's got to be our hydrogen. On the right, these are our flame tests. So you need to know colours for your flame tests. Turning something from orange to colourless, that's our test for alkenes. Bubbling something through lime water and seeing it turn cloudy, this is our test for carbon dioxide, bottom left. And that looks like a pH probe, so that's testing for pH. So just make sure you're comfortable with those. There are many others as well.